Hello students, my name is Darshan. I am your maths prof. So now we are starting the second chapter, that is the basics of algebra. In some books it is written as just algebra or making sense of algebra, all are same thing. So as you can see in this session, in this whole chapter, the contents are divided as: first we'll learn about the algebraic expressions, then we'll see how you can add given algebraic expressions, as well as we'll see the subtractions of them, then we'll see the multiplication of the algebraic expressions, then there's a division of algebraic expression also, and in the end the indices. I've already told you that in first chapter there is a topic indices, and the same topic is repeated in the second chapter. So here we'll give it a quick revision about the indices, and then for the full explanation of the indices, as well as all the questions are also same only, so you can check out all the videos which we have created for the first chapter indices, where there is one dedicated video in which I have explained everything about the indices, all the identities, and how you can solve the questions based on that. These questions will be algebraic indices as well as number indices, all kind of questions paper 2 and paper 4 we have covered in that chapter 1 videos, so you can check out those videos. So mainly in this chapter 2 will be covering this first 5 topics, and this indices will be repetition of the first chapter only. Okay, so let's start. Yeah, the first topic is algebraic expression. So what are the algebraic expressions? Algebraic expressions are basically the expressions made up of variables, constants, and the algebraic operations. Now variables, that means we use English letters here: x, y, z, a, b, c, d, whatever you want we can use that. And constants are basically numbers, real numbers, which we have already learnt about that in first chapter. What are the real numbers, you must know that. And then all algebraic expressions, so that is addition, subtraction, multiplication, and division. So any expression made up of all these things, they are called algebraic expressions. I'll give you some examples. Let's say in the first example, I can say 2x square minus 3xy plus 33x cube. Now if you see, this x and y both are variables here, and this 2, 3 and 33, they are coefficients, but they are constants. They are basically just numbers. Now one thing I want to make it clear, that how many terms are there in the algebraic expressions. Terms are 3 terms. Whenever you specify a term, any term is specified, and you can differentiate the terms using addition and multiplication only. So this 2x square is the first term, then this 3xy is the second term, and 33x cube, that is the third term, because there is addition and subtraction sign in between. If they have asked you like this, let's say 3x into y plus 7z. Now if you see how many terms are there, there are only 2 terms. I'll tell you why. Because this multiplication, x into y, it is considered as a single term. Whenever there is a multiplication or division, it is considered as a single term. So that means this 3xy is the first term, and the 72 is the second term, and they are separated by plus. Any algebraic terms are separated by plus or minus sign only. You cannot differentiate them using multiplication or division. Clear? I'll give you another example. Let's say 7x divided by y square plus 32 y square times x minus 17 z square. How many terms are there? There are 3 terms. Why? Because this 7x divided by y square, you cannot differentiate the term using multiplication or division. So whenever there is a division or multiplication, they are not different terms, they are considered as a single term. So this is nothing but 7x upon y square, which is a single term, then plus 32y square times x, that is another term, second term, and minus 17z square, this is the third term. So these are the algebraic expressions where there are algebraic terms. In each term you can find variables, coefficient, constants, as well as the multiplication and division in single term, but the terms are separated using addition and subtraction sign only. Clear? Now let's see what are the like terms in the algebraic expressions. So like terms are basically exactly same variables and equal powers of the variables. The coefficients could be different, but the variables must be exactly same, identical, as well as their powers should also be identical. The example is given. See this, the first example here. If you see the first term, that is 3x square, and the second term, that is 4x, though the variables are same, the variable is x only, but here in the first term the power of x is 2, and the second term the power of x is 1, because there is no power, so I can call it 4x raised to 1. So they are not like terms. But if you see the third term, it has x only, so same variable, then same like first, as well as the power is also 2, which is exactly same as the first term. So this is why this 3x square and this x square, they are considered as like terms. Similarly, this minus 4x, which is the second term, and this minus x, both have the same variable x as well as same power, x to the power 1. So they are also like terms. So if I write the pair of like terms here, so like terms are 3x square and x square, that is first pair, and minus 4x and negative x, they are also like terms. See the second example, 5xy minus 4 plus 3yx minus 6. Now you see in the first term, x and y, two variables are there and both have the same power, 1 and 1. And you observe the third term, that also has x and y, two variables only, and both have the same power. So that means they are like terms. Sometimes students make mistake like this. In the first term it is written x times y, and the third term it is written that y times x, but both are same thing, because multiplication is commutative, so xy and yx both are same thing. Okay, so they are considered as like terms because they have same variables with the same powers. So if I write like terms here, so 5xy and 3yx both are like terms, as well as this minus 4 and minus 6, both are constant terms only, they don't have any variables, so they are also considered as like terms. So it is another pair of like terms, that is minus 4 and minus 6. Okay, understanding the like terms are very important when it is addition or subtraction of algebraic expressions, which we are just seeing. Okay, so this was the basics of algebraic expression. Now you already know that what are algebraic expressions and what are the like terms in the algebraic expressions. Now let's see how you can add or subtract algebraic expressions. So in the first session we'll be covering the addition and subtraction of algebraic expression, and that multiplication and division will cover in the second session. Okay, see how you can add the algebraic expression. The topic is sum of the algebraic expressions. Now while adding two or more algebraic expressions, the like terms are added to each other. So basically the concept of like terms is very important, as I said. See this first example, there are two algebraic expressions. This is the first expression which is given in the bracket, and there is another expression second, and it is also given in bracket. So first thing, open the brackets, and while opening the brackets, when you are adding the terms, it's very easy, because if there is no sign before the bracket, that means it is considered as a plus sign, and whenever there is a plus sign before the bracket, while opening the bracket, you don't change the signs of any term, so all the terms remain as it is. But if there is a negative sign before the bracket, which we'll do in the next slide, which is about the subtraction of the algebraic expression, then you change signs of each term. We'll discuss it later. Right now because there's a plus sign before the bracket, you don't change the sign. So it is 12x square minus 4x plus 3y as it is, plus 17x as it is, minus x square as it is, and plus 8 as it is. Okay, so we just opened all the brackets. Now you see the like terms, I'll collect the like terms together so that it will be easier for me to add or subtract them. So you see 12x square and minus x square, they are like terms of each other. So let's bring them together with their signs. So this 12x square is a positive, I'll write it as it is, but this x square, which is also a like term of 12x square, but it is negative, so I'll write minus x square. Now similarly, if you see this minus 4x and positive 17x, they are also like terms, so I'll write them together, minus 4x plus 17x. Then other two terms left, which are 3y and 8y, they don't have any like terms with them, so I'll write them as it is, so 3y plus 8 as it is. Clear? Now we can add or subtract the like terms by just adding or subtracting their coefficients. The variable part remains as it is. You see this 12x square and minus x square. Minus x square means it is minus 1 times x square. So just 12 and minus 1 will be resolved. 12 minus 1 is 11 only. So I'll write 11x square. You see, I'm just adding or subtracting the subtracting the coefficient. So 12x square and minus 1x square. 12 minus 1 is 11x square. Similarly, this minus 4x plus 17x. So that is just doing minus 4 plus 17, which is positive 13. So that's positive 13x. You see, I am putting the variable as it is, just I am adding and subtracting the coefficients. Then this 3y plus 8, because they don't have any like terms, they will remain as it is. Clear? So this is your answer, 11x square plus 13x plus 3y plus 8. I hope it's clear. Let's see another example also. Here, let's open the brackets first. In addition, opening the bracket is very easy. Just remove the brackets without changing any signs. So 13xy minus 32x square y plus 8 plus 7 plus 9xy square minus 17x square y. You see, I haven't changed any sign of any term. I have written all the terms as it is. Now let's collect the like terms together. Now when you see 13xy, it doesn't have any like term, so let's write as it is. Then this minus 32x square y and this minus 17x square y, second term and last term, they are also like terms, so let's bring them together. So minus 32x square y minus 17x square y. Now this 8 and 7, they are also like terms because they are constants, they don't have any variables, they are considered as like terms. So plus 8 plus 7, and this little guy 9xy square, it doesn't have any partner with it, so we are just putting it as it is, so 9xy square. Now let's add or subtract the like terms. So 13xy will remain as it is because it doesn't have any like term, it's single. Minus 32 minus 17, minus 32x square y and minus 17x square y. So I'm just adding or subtracting the coefficients. X square y will remain as it is, and minus 32 minus 17 is minus 49 x square y. Now 8 plus 7, they are also like terms, so if you add 8 plus 7, that is 15, and this little guy 9xy square remains as it is. So this is your final answer. So this is how you add the algebraic expressions, by first opening the brackets and then adding, keeping the like terms together, and then in the end add or subtract the like terms and simplify it. I hope it's clear. Now let's see another third example also. Yeah, see this 8x cube plus 7x square plus 9 as it is, plus minus 3x, so that is just minus 3x, plus minus 8x cube, that is just minus 8x cube, and minus 17. You see, I haven't changed the sign of any term. 3x was already negative, 8x cube was already negative, and 17 was also already negative. Now let's bring the like terms together. This 8x cube and minus 8x cube are like terms, so let's bring them together. Then this 7x squared doesn't have any like term, so keep it as it is. Then this 9 and minus 17, they are like terms, so let's bring them together, 9 and minus 17. And then this fellow minus 3x will remain as it is because it doesn't have any partner with it. So now 8x cube minus 8x cube, that is 0x cube, so you don't need to write anything, it's just 0. Then 7x square as it is. Then this 9 minus 17, 9 minus 17 is minus 8, and minus 3x as it is. So this is the final answer, 7x square minus 8x minus, 7x square minus 8 minus 3x. Clear? Okay, let's jump to the subtraction of algebraic expressions. So the subtraction is more or less same like the addition. It's a sum of the algebraic expression only, but while opening the brackets you'll have to make sure that if there is a negative sign before the bracket, you change the sign of each term. See this, I'll show you. So see this first example, the 12x square minus 4x plus 3y, that is the first expression, and there isn't any sign before the bracket. If no sign is given, it is considered as positive sign, so don't change the sign of the terms which are there in the first bracket. Just open the bracket as it is, so 12x square minus 4x plus 3y. Now this 17x minus x square plus 8, that is the second algebraic expression, but there is a negative sign before that. So while opening the bracket, you will change the sign of each term. So the 17x, which is right now positive, I'll write it negative 17x. This x square, which is right now negative, while opening it will become positive x square. And this 8, which is right now positive, while opening it will become negative 8. This is the only difference between addition and subtraction. Now it's very easy, just the same thing, just bring the like terms together and then solve them. This 12x square has a like term x square, and that is also positive, so 12x square plus x square. Then this minus 4x and minus 17x, so they are also like terms, so minus 4x minus 17x. Then this 3y as it is because it doesn't have any like term, and this minus 8 also as it is. So this 12x square plus x square, that is 13x square, and minus 4x minus 17x, that is minus 21x, plus 3y minus 8 as it is. Clear? So subtraction of algebraic expression is more or less same like the addition of algebraic expression, just while opening the brackets, if there is a negative sign before the bracket, change the sign of each term. Clear? Let's see other two examples. Yeah, so this first algebraic expression, before the bracket there is no sign, so it is considered as positive sign. Don't change the sign of any term in the first expression, so that is 13xy minus 32x square y plus 8 as it is. Now you see the second expression, because there is a negative sign before that, I'll change the sign of each term inside the bracket. So 7, which is positive right now, it will become negative 7. 9xy square, which is positive, it will become negative 9xy square. And this minus 17x square y, which is negative right now, it will become positive, so positive 17x square y. Now let's bring the like terms together. This 13xy doesn't have any like term, it will remain as it is. This minus 32x square y and 17x square y, they are like terms, so let's bring them together. Minus 32x square y plus 17x square y. And this 8 and minus 7, they are also like terms, let's bring them together. They are already together, by the way. And minus 9xy square, it doesn't have any partner, it will remain as it is. So 13xy as it is, minus 32x square y plus 17x square y. Minus 32 plus 17, that is minus 14x square y. Then 8 minus 7 is 1, and minus 9xy square as it is. Clear? Let's see another example. Let's quickly open that. First expression, all the terms will remain as it is without changing any sign, because there is no sign before the bracket, it is considered as positive. And all the signs from the second bracket will remain, will change, and all are negative, so they all will become positive. Positive 3x, positive 8x cube, and positive 17. Now you see these two like terms are already together, but this 9 and 17 are not together. Let's bring them together. So 8x square plus 7x square plus 9 plus 17, and this 3x and 8x cube, they don't have any like terms, they will remain as it is. So let's resolve all the like terms. 8x square plus 7x square, that is 15x square, 9 plus 17, that is 26, and 3x plus 8x cube as it is. Clear? So that was it for today's session. Here we discussed about the algebraic expression, what are the like terms, and how you can add or subtract the algebraic expressions. In next session we'll see multiplication and division of algebraic expression, and then there will be third session of the explanation where I'll explain little bit about the indices. But as I told you, it's completely revision of the first chapter, so I would suggest first you watch the indices part of the first chapter, and it is exactly same in the second chapter. You don't need to study it again. All the questions are also exactly same, paper 2 and paper 4. So in this playlist I'll add the same question solving videos. Clear? So till then, just keep practicing and keep supporting me. This YouTube channel is just for you. Like and comment. If you like the video, just give me comment, and it will be very helpful for me. Thank you.